They know I can't help these, cause they know they can never touch these.
Hello everyone, so welcome back to my channel. Alright, so in this video we will talk about the four pillar of the object oriented programming language. Okay, so in the last video we have understood about the constructor. Okay, so in this video we will talk about the object oriented programming. Now we will see what is the object oriented programming as we have understood the simple glimpses of this object oriented programming. So you already know that. Now let's discuss the four pillar, basically four main pillar of the object oriented programming. Okay, so these four pillar are abstraction, encapsulation, inheritance and polymorphism. Okay, so now in this video we will be giving you an overview and a theoretical answer to abstraction, encapsulation, inheritance and polymorphisms. Okay, and from next video onwards we will be adding coding them one by one and understanding them better with code. Okay, so let's start with our first pillar, that is abstraction. Okay, so in order to explain abstraction, let's take an example. Now I guess that you all have drive, like you know that how to drive a car. Okay, so if you have a car, correct, so now a car basically has three pedals, correct. One pedal is clutch, then you have brake, and then you have accelerator, right, a race. Okay, now what happens when you press this button? Okay, when you press this pedal, the car speeds up. Okay, but when you press the particular pedal, the car stops. Okay, and when you press the particular pedal, now you have the ability to change the gear. Got it? Correct. So what happens, like if we talk about like what is the internal implementation of the class, like what exactly happens when you press the clutch? So you will say, I don't know, like there is something I don't know what is the system, but yes, when I press the clutch I can change the gear. No, but what happens on the internal side I don't know. Just we are pressing the button, we are just pressing the clutch, just pressing the accelerator, just pressing the brake, but we don't know about the internal things, right? Similarly, when you say that I press brake and my car stops, now what happens on the back end, or what happens internally in the mechanism, I don't know. And the same goes for the rest as well, correct? And similarly, let's say that most common example in your house, you have a switchboard, correct? You have a switchboard in which you have many switches, right? And you have regulator also. Now when you press the switch, when you press this switch, what will happen? Basically your light turns off when you press the switch, right? Let's say your fan turns on, and when you press this switch, let's say your TV turns on, and this regulator can control the speed, right? Regulator can control the speed of your fan, which is absolutely correct, right? So all this switch, and you have multiple scenes, and from the switch you are controlling the fan speed, you are doing you are clicking on the button, switch button, and fan is on, fan is off. But if I ask like what companies and what how wiring is done, what is the, like what is done inside this regulator, which wire is going through where you which wire is going through where you don't know, right? Correct. So that is all magical, and this is all black box and hidden to you, correct? Okay, so you have seen, you know that only what you should know, correct? So abstraction basically means hiding the internal implementation, showing the essential data. Okay, the switch is your essential data, clutch is your essential data, and brake is your essential data, but internal things is hiding, internal implementation is hiding. So that's called abstraction, as I already told you, but I am giving you the broad example. Okay, so both of this example you are only exposed to some essential details. Right here pedals are exposed to you, and here buttons are exposed to you, but the internal implementation of these both things are hidden. So that's the meaning of abstraction. Okay, so basically in coding terms, what you say is when you have, whether you write a code in object oriented programming way, so okay, so what you can do is you can basically abstract the logic, okay, you can basically abstract the thing, and you can basically move the public, like using the public access modifier, okay, and you can only expose essential details out, like we have seen in the previous video, right? Okay, so I abstracted the name, you and age from the user, and because user don't need that, and I only expose the essential details, okay. Okay, so like set name, get name, okay, I had made this one. If you will see here, if I'll go on the code, okay, so this is the set name, get name, okay, person. Here you can see this is the set name and get name, okay. So this essential information, this is like set name, get name, this essential details we are exposing, okay. Okay, so that is the first pillar, that is abstraction, okay. So OOPS provide you an abstraction with which you can hide the internal implementation of things and expose the important things, okay, I can say essential things to the user, okay. So that was our first pillar. Second comes encapsulation. Encapsulation means bins, okay, we can say bins as well. Now you already know what is encapsulation basically. So we have already seen that we have a person class, okay, we have a person class. Let's say we have an animal class. So what we are doing here, we were doing is all the properties and all the methods that were related to the person, okay, and we were encapsulating it inside a person class, okay. See here we have animal class, okay, or we have encapsulated inside the main class, okay. Okay, all the property, all the method that were related to the person, we were encapsulated inside a person class, okay. Here, okay, we already added this example, okay, we already given this example to you, but right now I am just showing you verbally, okay. Okay, so similarly all properties, all the matter that belong to animal, we were encapsulating that inside the animal class, okay. Right now this is animal, dog extended animal, we were making this sound method, okay. Okay, so if we don't have object oriented programming style or design, so what will happen is will be having function for each one of them, and it will be really difficult for us to encapsulate them, okay. So we will get confused in some point of time, okay. So that which function belong to what. So object oriented programming provides you with something known as encapsulation, in which you can bind, okay. So you can encapsulate your method and the properties inside the class, okay. Okay, now comes to the inheritance. So what is the inheritance? This is really interesting. So you can see what we are doing, we are inherited this properties, this is the animal class, and we have created this sound method, and we have inherited this animal class, and we are using this method, okay. So let's say that this is the particular guy. This particular one particular guy, and that particular person is your father, and your father basically has some properties, like he has a height, okay, he has some genetic, he has some, let's say he has some eye color and more other properties, okay. So now this is you, basically you are a son of your father, okay. So there is chance and most of the properties of your father will be same to you, right? So this is called is inheritance, correct? So what is has to do with OOPs? Basically what happens, you can inherit the properties from one class to another. Okay, here you can see this is the class and we have inherited these properties here. Okay, so this is called inheritance. Okay, so let's take an example, classic example. Let's say we have a car. Okay, and car can have some method like start engine. Now we have different brands like Kia, Honda, Mahindra. Okay, so what we can do is we can basically inherit the car class in all three of them and we can modify them a little bit. Okay, so with inheritance, basically what I did, I rescued this function, this start engine function, and modify a little bit according to the child class. Okay, so this car is parent and Kia, Honda and Mahindra are the child classes. Okay, so and the benefit of inheritance is basically reusability of the code. So that was our third pillar. Okay, so one of the last we have polymorphism. Polymorphism we have already understood, like we have different parameter with the we have mattered with the same parameter. Okay, a classic example we will take, your father is father, son, grandfather and boss depending on the situation. Okay, similarly plus operator behave differently from number and string, correct? So this is known as polymorphism. So these were theoretical overview or pillar. Okay, abstraction, encapsulation, inheritance and polymorphism. Okay, so like a father I have given example of father, like your father is father, okay, son and grandfather and boss depending on the situations. Got it? Like we have a different form, but we have a different form with similar properties with different method. Okay, like this we can say polymorphism. Okay, okay, so in the next video we will be coding them and one by one we will understand them. So that's it for this video and let's meet you in next video. Until then, bye bye and take care. Thank you so much guys. Bye.
You know I can't help these, cause they know they can never touch these.